are 6 possible outcomes, so similar with the die situation. When a particular key or something, I'm not really sure what they are tossing. Again, I have to dig up. A class of 52 students rolled pigs 3,939 times. I don't believe it. I'm going to have to add them up and make sure. So 1344 plus 1294 plus 767 plus 365 plus 137 plus 32. Indeed, it is the total number of 3,939 times. Fine. Use the results of this experiment, it's an experiment, right, to build a probability model for the way the pig lands. Fine. So then we have, I'm just going to label them 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, and 6. So event A if you want, event B, C, D, E, and F. So the probability of A will definitely be 1344 over the total number. So A occurs 1,344 times out of the total. For the second possibility, P of B is 1294 divided by the total number. And so on and so forth. P of C, 767 over 3939. And P of D is 365 over 3939. P of E, and then P of F, and then we'll create a table. So 137 over 3939 and 32 over 3939. Yes, I can do this very easily with a calculator. And here's how we do it. Go to Stats, go to Edit. If you want to edit list L5, if we don't need this anymore, you can go back and delete the list L1. So I'm going to enter 1344, next one 1294, 767, sorry. Okay, 1344, 1294, 767, 365, 137, and 32. And in the next list, I'm going to clear what I have. I'm going to divide list L5 by 3939 to get all the answers at once. So list L5, the previous list, divided by 3939. I don't want to do this by hand several times. So I have 0.3412, 0.3285, 0.1947, 0.0927, 0.0348, and 0.0081. I just created a probability model. All probabilities are between 0 and 1, and their sum has to add up to 1. Okay? So, probability model. The sum of all probabilities for each event from I equals 1 through 6, because that's what we have, must equal 1. And I'm hoping that they equal 1. Will I do it by hand? No. I'm going to go to Stats. I'm going to calculate. Go to Calculations, one variable, on list L6. I want list L6. And it better give me a sum of 1. Sorry. So it better give us the sum of 1. So the sum is 1 indeed. And I created such a probability model. So what is this? So in this particular case, we used the empirical method or the frequency. What does that mean? I counted how many times the first event appeared, I count how many times the second, and out of the total. I performed the actual experiment. So that's thought I turned it off. So I perform the actual experiment. That's the frequency method or the empirical method. Do we have another method of creating? So we used the results, we created, and now the estimated probability we already did. Would it be unusual to throw the last one, the leaning joler? Yes, it would be unusual because the probability is very low. So the probability is or maybe 1% if you'd like, if you want to round it up. So this is unusual. Is there another way of determining probabilities? Yes, on page 6. This is the second method. So the first one was using the empirical method, and now the second one is what I like to call, it's called classical method. What I like to call it is thinking method. This is not possible. So the classical method, we are not performing any experiment. We think. Thinking method. This is the thinking method. We are not performing an experiment. And here is an example about the thinking method. Now, I see we have about 12 minutes left. The quiz that we have for today, it will take like probably 4 minutes. Would you like to finish up this problem? We have time. Would you like to finish it? Yes. Okay. Yes, please. Okay. So we have a fair pair again of, but this time we have a pair of dice. So a fair die, our die we already discussed that. They're when we roll them, they're not weighted. I know some people, use that cheating method of putting more weight on one side or the other of a die, but we consider that they are fair, so they are equally, all the probabilities are equally likely. So rolling a die that is considered fair, it means that all side faces have equally likely chances of facing up. So that's why we call them fair. Okay, the possible outcomes of this experiment for a pair are these. These are the possible outcomes. 1, 1. 1, 2. 1, 3. 1, 4. 1, 5. 1, 6. 2, 1. 2, 2. 2, 3. 2, 4. What does this mean? First die gives a 1, the second one gives a 1. First die gives a 1, the second one gives a 2, and so on and so forth. So 2, 5, 2, 6, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 4, 5, and 4, 6. 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, finally 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6. First question. What is the sample size? Sample space. Everything from 1, 1 to 6, 6. And there is nothing else. This is the sample space. This is all that can happen. How many? 6 times 6, 36 outcomes. 36 possible outcomes. Okay, first question. Compute the probability of rolling a 7. So, to roll a 7, there is no such thing as 7, but this should be explained what the 7 means as the sum. So, the probability of getting a sum of 7. You can call this event A. In short, the probability of A. So, first of all, how can I get a 7? I can get a 7 from 1 plus 6. I can get a 7 from 2 plus 5 or 5 plus 2. I can get 3 plus 4 or 4 plus 3. So how many options I have for 1 plus 6 or 6 plus 1? 1 plus 6, 6 plus 1, I have 2. So these are 2. How many possibilities I have with 2 and 5? I have 2 and 5 and 5 and 2. So these are 2. What about 3 and 4? So I have 3 and 4 and 4 and 3. So these are other 2 possibilities. So I know that the total number of outcomes is 36. 2, 4, 6. 6 divided by 36. Now you understand why this is the thinking method, I call it, or classical. Because I don't perform the experiment. I just think of what possibilities are there to determine this. Well, when I simplify, this is 1 divided by 6. The second question was asking us to the probability of rolling a 2. So, sum of 2. Okay, what is the probability of rolling a 2? So, the sum of 2 can only be created with 1, 1. There is nothing else that I can add up to get a sum of 2. So this will be 1 divided by 36. There is no other option. And we can determine any other probabilities. So I'm going to just create another question. The probability they're equal. Like 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. Here they are. 1, 2, 3, 4, 5, 6. Again, this is 6 over 36, or 1 over 6. Any questions?